In this chapter, we are looking at geometry. We're looking at perimeter, area, volume, and surface area. We're going to start with perimeter. So perimeter is the distance around the outside of a figure. It's how far around the figure is it. So what I want you to do is I want you to look at these three shapes here, and I want you to try and find the perimeter. I guess I'll work with the rectangle first. So I'll do the red rectangle, and then I'll have you work with the other ones. So the distance around the outside of the red rectangle here. If I find the distance along the outside, I've got 1, 2, 3, 4, 5 boxes on the left side. So 5 boxes there, that's 5. 5 boxes on the right side. If I count here, I've got 1, 2, 3, 4, 5, 6 on top. And of course, 1, 2, 3, 4, 5, 6 on the bottom. So the perimeter would be 5 plus 6 plus 5 plus 6. Now, there are formulas for this, but it's kind of ridiculous when you can just add the 4 numbers together and get your answer then of 5, 10, 22. So the perimeter equals 22. There we go, found the perimeter. Okay. So what I'd like you to do is find the perimeter of the blue triangle and the blue weird-looking shape thing. Pause it. I'm assuming you paused it. Try it. Get those perimeters, and I'll tell you what my answers are, and see what yours are, and we'll compare the difference. So the first one, the triangle. We just worked with Pythagorean theorem not too long ago. We've got a right triangle here. So this side is 4. This side is 3. And if you remember your Pythagorean theorem, you'd have leg squared plus leg squared equals hypotenuse squared. 3 squared plus 4 squared equals 25. So this would have to be 5, which gives us a perimeter then of something, what, 12. So the perimeter would be 12 for the triangle. For the weird looking shape thing, if you add up all the sides, and this is where you have to be careful, is in these little corners here, right here, this corner. You got to be really careful with some of those inside corners. And so to help with that, I've already gone ahead and written them in. And so if you add up all the sides that are in there, you end up with 46. And you can look at that on your own, but the perimeter equals then 46. And again, in those little corners here, you have to remember that you go up 3, I'm going to use a different color, you go up 3 here, and you go over 1 there. That's that you don't count that box once. You count this box right here twice. You count it once on the way up, and once on the way over, and then again you count this right here, 3 up, 2 over, 5 down. This one box right there is counted twice, because you have to go once this way and once that way. So when you're counting out those spaces, be very careful with those nooks and crannies. Perimeter ended up being 46. Okay, so that's perimeter. I think you've seen that before. Most of you can do perimeter. Let's look at something a little more complicated, area. So area, this came from farming. This came from how big is my field. And we had to find a systematic way of finding area. Now with a rectangle, it's pretty straightforward. You count the boxes. How many boxes are in this shape? And if you count them all up, you end up with, what do we get? 24. And there's 24. But a systematic way of doing it would be to say that there are 4 or 6, maybe 6 columns of 4 rows. So there's 1, 2, 3, 4, 5, 6 columns, and there's 4 rows. And so if there's 6 columns of 4 rows, we're looking at 6 times 4. 6 times 4 gives us 24. So 6 columns of 4 rows, we're going to have 6, and this is going to be 4. So the rectangle, the area of that rectangle, 24. And if we call the 6 side there, we're going to call that the base. If we do the base times the height of that rectangle, we're going to get the area. So I know some of you know length times width. We're not going to use length times width, and there's a reason for that. I'm going to use base times height because it's going to show up in a lot of other formulas. So length times width is not wrong, but we're going to go with base times height. And that particular rectangle is going to have an area of 24. Now, a parallelogram. Parallelogram is kind of like a rectangle that's fallen on its side. It's going to look something like that. And so a parallelogram has 2 opposite sides that are parallel. Both sets of opposite sides are parallel. And if we take this rectangle that I have here, and I cut part of it off, okay, you'll notice I've made that cut, but I have not changed the area. The area is still the same. I just made a little cut down the middle there. And if I move that section, I'm going to try this again. Here we go. If I move that section over here, now I have a parallelogram, but have I changed the area? No, I have not changed the area at all. All I've done is I've taken part of it and moved it. So it was here. I moved it over here. The area hasn't changed. It's still the same amount of material. So the area of that parallelogram is still 24. And if you look, the base hasn't changed. This side here is still 6. And the height hasn't changed. The height is still 4. But this diagonal is the only thing that's really changed. And so when we talk about area, when you say length and width, you have to be really careful, because the length might be 6 and the width is going to be some not fun decimal. And that doesn't work. We can't do length times width with a parallelogram. We have to look at the base and the height. And the base and the height are always at a 90-degree angle to each other. And so the base is 6, the height is 4, it's still going to have an area of 24. And so the area for a parallelogram, also base times height. We just have to be careful that the base and the height are at a 90-degree perpendicular angle to each other. All right, we've got two formulas then. Rectangle, area equals base times height. Parallelogram, area equals base times height. Let's practice these. So find the perimeter of these two shapes first, and then we'll find some areas. I'm assuming you paused. I'm assuming you found the perimeter. The perimeter to the first one here is going to be 38, and the perimeter for the second one is going to be 72. If you didn't get those answers, go ahead and click the link in the video. Otherwise, there should be a link after the video in the comment section and on the form as well. If you didn't get those answers, make sure you look at how to do them. Next question. I'm telling you the perimeter is 40. I'm telling you that this side is 12, and I want to know what would x have to be so that the perimeter would be 40 in this parallelogram. Pause it, give it a try on your own. I'm going to assume you paused it. I'm going to assume you tried it on your own and have an answer. I'm just going to go ahead and tell you that the answer is 8. If you did not get 8, again, click on the link on the video. Otherwise, go to the other links and watch how to get that answer, because you will need to be able to do that on your own. Part of your assignment will also ask about graphing and finding area from there. We've done graphing before, so I'm going to graph these 4 points. -1, -1, there we go. 3, -1, there we go. 5, 3, okay, there we go. And 1, 3. Now, if I went too fast for you, pause it and catch up. Looks like when I connect the dots, I have a parallelogram. I can find the area of a parallelogram. That's what it says to do right here. Graph the figure and find the area. So again, you can pause it if you want, but I'm going to go ahead and find the area here. If I look at the base of that parallelogram is 1, 2, 3, 4. Or if you prefer up here, 1, 2, 3, 4. It doesn't really matter. But the base is going to be 4. And the height, remember, the height is not the diagonal. That is not the height. The height and the base are always at a perpendicular angle. They're always at a 90-degree angle. So the height from top to bottom, from the very top to the very bottom is the height, is 1, 2, 3, 4 as well. So if I know my parallelogram formula, it's the base times the height for finding the area, which is going to be 4 times 4, which gives me an area of 16. Okay, we found the area. Pause it, try this one on your own. Graph it, and then find the area of the figure. I'm going to assume that you paused it. I'm going to assume that you graphed it. So we've got -3, 2. Oops, sorry, -3, -2. -3 at -2 for my first point. 1, -2 for my second point. 1, 3 for my third point. And -3, 3 for my fourth point. Looks like I have a rectangle. And if I find the area of my rectangle, I'm going to do the base times the height again. And so if I count 1, 2, 3, 4, I'm going to have a base of 4, a height then of 1, 2, 3, 4, 5, right there. So if I do the base times the height, I get an area of 20. Moving right along. Find the perimeter and the area of this figure here. I'm just checking the time quick. So find the perimeter and the area. Pause it, give it a try on your own. I'm going to assume you paused it. Now, at this point, I'm going to put the answers on the board. It is your responsibility as a learner, as somebody who is learning, that if you don't get the right answer, you look to see how to do it. Because I'm going to teach you how to do it if you actually click on the link. But if you don't take the effort to learn the material, I can't teach you if you won't accept the responsibility of learning. And so you have to go to the site. You have to go to the video. If you go to the video and you're still not sure how I got it, then ask questions. Type questions in the box in the form and ask those questions in class. But if you don't even go to the link and you just write down the answer, say, oh, well, I didn't know how to do it, that's not learning. And you need to learn. Okay, so perimeter. The perimeter of this figure is 52. And if you didn't get that, make sure you click on the links. And the area of this figure is 72. So if you got those right answers, awesome, great. If you didn't get those answers, make sure that you click on the links and follow those examples. Last one, again, find the area of this figure. You can find the perimeter if you want, but the directions are only to find the area. Okay, again, I'm going to assume you paused it, tried it on your own. The area of this figure is 108 square feet. 108 square feet. Because when we multiply, like let's say if we're just looking at this rectangle here, we're just looking at this rectangle here, if you do 12 feet times 5 feet, and you have to be a little bit, you have to accept that the feet and the 5 are not connected necessarily. If you rearrange this a little bit with the commutative property, I suppose, you could do 12 times 5 times feet, which isn't really what's going on, but it makes it a little bit easier to think about it that way. In fact, I'm going to go ahead and get rid of that. We'll just have 12 times 5 and feet times feet. 12 times 5 will give you 60, and feet times feet would be 2 feet, which are feet squared. So that's kind of what's going on. You're multiplying your feet times your feet, and you get square feet, which would be hard to walk in, but you have square feet. And so we've got 108 square feet for that one. And that's where we get that unit of square feet from, is because we have little squares, and they're all square feet, even if they don't look like feet. They're all square feet. Okay, so try the form, or do the form, do the assessment, and we'll look at these in class.